Hello students, myself Professor Chaitali Patil, and today in this video I am going to teach you the basic concepts of hashing and will discuss one collision resolution technique in detail. So let's start. Objective of this lecture, after this lecture you will be knowing some hashing concept, what is hash table, different hash functions, what is collision, then collision resolution techniques, which are different collision resolution techniques are there, and one collision resolution technique in detail. My address, so we'll see all this detail in next example. Okay, next method is multiplication method. In this method, x, a key, can be multiplied with some constant value k. Generally, this k is nothing but a fractional value, and mostly this value is in between 0 and 1. So any fractional value, any fraction between 0 to 1 can be used as a constant k that is multiplied with a x, and after that first few digits can be extracted as a home address for this function. Okay, so here we have seen hashing is nothing but, or hash functions are nothing but a simple mathematical functions. Okay, so here in this example we'll see how a simple hash function, here I have used a modulo division or division method. Okay, so we'll see how all these keys are mapped by using the hashing function into a hash table. Here this is the hash table. The size of hash table is a 10. The index is from 0 to 9. Here I have used key space as an integer. All these are 7, 18, 41 are the keys which we have to map, we have to store into this hash function, and the hash function is h of k is equal to key mod table size. Okay, so this is a very simple function that will see how all these keys can be mapped by using this hash function into this table. Okay, so first key is 7. So 7 mod 10. Okay, we know mod operator gives us the remainder. So 7 mod 10 will get remainder as 7. So this key 7 will be inserted in the location at the location 7. Next key is a 18. So 18 mod 10. So 18 mod 10 will get the remainder as 8, and so 8, as we get 8 as a home address, so 18 is placed at 8th position in a hash table. Similarly, the next number is 41. The next key which we have to insert is 41. So applying the hash function on this key 41, 41 mod 10, we will get remainder as 1. So this one is nothing but the home address for this key 41. So in this hash table, 41 will be placed at the home address 1. The next key which we have to insert is, say suppose 34. So 34 mod 10. So 34 mod 10, we will get remainder as 4. It means for a 34, the home address is 4. So on a 4, we will store a record, will place this record 34. And the last record is 10. 10 mod 10. So 10 mod 10 is a 0. It means at the home address 0, we will place the record, we'll place this key 10. So this is how a simple hashing function works. Okay, so we have considered a very simple hashing function, key mod table size. Okay, so this is what, or this is how the hashing works. Now consider there can be more than one keys that are that have a same home address. For example, here the last record we have considered as 10. So 10 mod 10, we get remainder as 0, and that's why we have placed this element 10 at home address 0. Now consider, suppose the next key is as 20. So 20 mod 10, again, the remainder is 0, and we have to insert that record at home address 0. But as already there is one record present at the location 0, so we cannot insert 20 currently at the home address 0. Right? So this is a collision, and here we call the 10 and 20 as the synonym. Why? Because 10 and 20 having both are having the same address. Okay, so generally, um, we have seen what is collision, right? So what is the ideal hash function? The ideal hash function should be such that it should compute the home addresses fastly, and there should be a minimum or zero collision. But in real life or actual implementation, zero collision is often impossible. And that's why if the collision occurs, we need some methodology, some way to resolve that collision. So if a keys are integer, then that can be mapped easily with the uh, easily in a hash table. But if the keys are a string, then we need some algorithm, we need some method to convert that string into an integer and then apply the hash function on that integer. A table size can be a prime number, and larger the table size, we can use this for collision avoidance. But still, there can be a collision, and for that, we require a collision resolution technique. So, again, we'll see what is collision when two keys map to a same location in a hash table, and then we say that there is a collision, right? And there are few methods for a collision resolution. Addressing used, but some of the authors, uh, some of the books use some very confusingly other terms. For open hashing, a chaining is used, and for open addressing, close hashing word is used. But all these are a confusing words. So here I am going to use the word chaining or a separate chaining and open addressing. Okay, so now we will see the separate chaining in detail. Okay, so all the keys that map to the same table location are kept in a linked list or as a chain. Okay, in separate chaining, consider there are 10 buckets, or we can say there are the hash table size is of 10 from 0 to 9, And suppose we want to insert these keys by using a simple hash function h of x is equal to x mod 10. Okay, so if we want to insert all these keys in this table by using a separate chaining method. Separate hashing function is very simple, but if a collision is there, then we need a collision resolution technique, and we are going to use a separate chaining method here for this example. Okay, so first key is a 10. So 10 mod 10 to insert next key, that is 86 in a hashing table. So 86 mod 10 will get the remainder as 6. It means now at the home address 6 there will we have to form a new linked list, and we have to insert the record, the one record 22. And now we want to insert 12. Now there are two possibilities. 12 and 22 are mapped with the home address 2. 12 can be inserted before 22, or a 12 can be inserted after 22 node in a linked list. Here I have inserted 12 before 22. Now, coming to the last record is 42. 42 again, 42 mod 10, we will get remainder as 2. It means again there is a collision, and now after considering a 42 as a key, 22, 12 and 42, these are the synonyms. Now, where to insert the 42? Yes, definitely we have to insert it against the record 2. It means we have to create one node here in a linked list, as we have considered, as we have inserted 12 before 22. So, here to insert the 42, we have to insert 42 before. Consider this example. If we want to search 22 in this case, the time complexity will not be a big O of 1. Right? If we want to search 22, so 22 mod 10 is 2, but immediately we are not getting the record 22 and we have to traverse the linked list. So case time complexity can be a linear for a hashing. And the best case time complexity, yes, obviously it is a big O of 1. Okay, so again we can reduce the worst case time complexity, but that depends on the hash function. If the hash function is not a good function, then we cannot achieve the aim of a best case time complexity scenario in hashing. A separate chaining can use a different data structures. For example, it can use a array, it can use a linked list, or it can use a hybrid combination of linked list as well as array. In a linked list, a record can be newly coming key can be inserted at the beginning, or it can be inserted at the end of the linked list. That depends. A sorting, while inserting a record, a sorting can be performed, but that will lose the performance. Now, how to find out the load factor? Load factor is generally a terminology that is used with the hashing, and a load factor is denoted by the term lambda. So lambda, that is load factor, is equal to n divided by the table size, where n is the number of records, number of items currently present in a table. So, what is the load factor for this example? Consider this example, and now we have to find the load factor lambda. So, as a formula, n by table size. Here the table size is a 10, and currently there are 5 records present in this example. So, load factor for this example is 5 by 10, that is 0.5. So, load factor for this example is 0.5. Now, consider the one more example. This is the example, and what is the load factor for this? If we observe this example carefully, then we can say that there are more synonyms present, and that's why we need a good collision resolution technique. If we observe this example, we can say a separate chaining is used as a collision resolution technique here in this example, right? And we don't know what is the hashing function. Hash function can be anything, but here a collision resolution technique is definitely a separate hashing, and there are more synonyms. 71, this should be actually a 21. 71, 21, and 31 are the synonyms. 42, 12, 22 are the synonyms. 63, 73 are the synonyms, and they are placed against the record 3 likewise. Okay, so there are many synonyms present, and if we find out the lambda, that is the load factor, for that we need to find out the number of records inserted. So number of records inserted are, so there are 21 records, and the table size is 10. So 21 by 10, lambda or the load factor is 2.1. Now, whether now, if we want to comment whether the hash function is good or not for this, if the load factor is around 1 for a separate chaining, then we can say it is good. Okay, so we like to keep the load factor around 1 for a separate chaining. Here in this example, the load factor is much more than the 1. Here it is 2.1, so we can say that we need some or when a load factor is more than 1, then the aim of using the hashing is not getting right. What is the aim? To access any record, to delete or search any record at the complexity of big O of 1, but here average time complexity of big O 1, but here as the load factor is 2.1, it means there are many synonyms, and is the aim of hashing is not achievable. So from a load factor, we can say whether the aim of a hashing is achievable or not, and that's why we need the load factor. What is the formula to find out the load factor lambda? The formula is very simple: number of records currently present in a hashing divided by the size. Now we'll see the next operation, that is a delete operation on separate chaining. Okay, suppose we want to delete one record. Consider if we want to delete a record 22, how to delete that record? 22 is a key, and that we need to delete. So 22 mod 10, that is 2. So directly go on a record 2, go on the home address 2, and check whether the record 22 is present. But here it is a linked list against the record 2. So we have to traverse the linked list until we get a 22. If the 22 is present against the linked list 2, then we can say a record is present and it can be deleted. But if a key is not present, then the record is not present in a hashing. Okay, so 22 mod 10, it means 2. So we have to traverse this linked list over here. First record is 42, traverse the linked list till we get a 22. So at third node we are getting the record 22, and as we perform the operation in a linked list, delete a record from a linked list, the same operation can be performed here as we are using a linked list, and we can delete a 22 here. So likewise, a delete operation can be performed. For that, first we need to find a record in a table. If a separate chaining is used as a collision resolution, then we need to traverse a linked list and we can perform a delete operation. Resolution technique, that is a separate chaining in detail with insert and delete operation on that. Thank you for watching the complete video. Thank you.